Hey there, welcome. Have you ever felt like you're just drowning in data, buried under this mountain of numbers, trying to figure out what it all means? Well, you've come to the right place. Today, we're going to demystify factor analysis in SPSS. We're going to turn that chaos into some real, clear insights.
All right, so here's our game plan for today. First, we'll tackle that whole challenge of data complexity. Then we'll get into what factor analysis actually is. After that, it's all about prepping your data, actually running the analysis, and then, the fun part, interpreting the output. And we'll wrap up by turning you from a novice into a pro.
So let's kick things off with a problem I'm sure anyone who's ever looked at a spreadsheet knows all too well. Just way too much information.
I mean, does this sound familiar? You've got this massive survey, right? Dozens of questions, tons of data points, and you're just staring at it, and it's a complete tangled mess. You can't see the forest for the trees, you know?
But what if there was a way to untangle that mess? What if you could find the hidden structure, the real story that all those little data points are trying to tell you?
Well, that's exactly where our solution comes in. Let's dive into the tool that brings order to all that chaos, factor analysis. Okay, so what is it, really? The most important thing to get is this. Factor analysis is like a super smart sorting hat for your data. It looks at all your variables, figures out which ones are kind of related, which ones move together, and then groups them into these bigger, broader concepts we call factors. The goal? Simplify things without losing what's important.
Now, you should know there are two main flavors of this. There's confirmatory factor analysis, or CFA, which you'd use if you already have a pretty solid hunch about how your data is structured. But today, we're focusing on its cousin, exploratory factor analysis, EFA for short. This is your go-to when you're just diving in, trying to discover those hidden patterns for the very first time. Okay, so before we can just jump into SPSS and hit the go button, we've got to do some prep work. Seriously. Think of this like a pre-flight check for a pilot. If you skip these steps, your results could be totally unreliable, and nobody wants that. So first things first on our checklist, make sure your data is ready to go. That means all your variables have to be numeric. You'll also need a plan for any missing data. The easiest thing is usually just to tell SPSS to ignore those cases. It's called list-wise deletion. And super important, you need enough data. A really good rule of thumb is to have at least 5, but ideally 10, people or observations for every single variable you're looking at.
All right, once you've got those basics handled, we're at the next stage. Two crucial tests that act like gatekeepers. And I mean it. These are non-negotiable. They literally tell you if your data is even appropriate for factor analysis to begin with.
First up is something called the KMO test. All this really does is check if your sample is good enough for this kind of analysis. The number you need to remember is 0.6. If your KMO value is above 0.6, you're golden. It's a green light, you can go ahead.
Our second gatekeeper is Bartlett's test of sphericity. I know, it sounds super complicated, but it's actually asking a really simple question. Are your variables even related to each other at all? Because if they're not, there's no point looking for patterns, right? What you want here is a significance value, a p-value, that's less than 0.05. That tells you, yep, there are relationships here. Let's keep going.
Okay, our data has passed the pre-flight checks, we've gotten through the gatekeepers, and we are cleared for takeoff. So let's get into SPSS and walk through the exact steps to get this thing running.
It's actually pretty straightforward. You're going to go up to the top menu, click Analyze, then head down to Dimension Reduction, and from there, just click on Factor. A new window will pop up, and you just have to move all the variables you want to analyze into that variables box.
All right, now for the settings. These are super important for getting good results. Under extraction, we're going to stick with the default rule. Only keep factors with an eigenvalue greater than 1. An eigenvalue is just a measure of how much info a factor holds, so this rule basically says we only want factors that are at least as useful as one of our original variables. Makes sense, right? Then, and this is so important, under rotation, you're going to choose Varimax. This little trick makes the final output way easier to read. Trust me. And finally, under options, we'll just tell it to hide the small, unimportant numbers to clean things up.
And just like that, we've done the heavy lifting. We hit OK, SPSS does its thing, and now we have a bunch of tables and charts. This is the moment we've been waiting for. Let's decode this output and see what we found.
So the first place you're going to look is this total variance explained table. And check it out. Remember our eigenvalue greater than 1 rule? Well, right here we see that factor 1 and factor 2 are both above 1, but factor 3 is down at 0.8. So just like that, it's out. We've taken all that complex data and boiled it down to just 2 core factors. Pretty cool, huh?
Next up, you'll see a Scree plot, which is an awesome visual way to double-check your work. You'll see the steep cliff where the strong factors are, and then suddenly the slope flattens out. That little bend is called the elbow, and it's a huge hint. It basically confirms that you should only keep the factors before the bend, which in this case is our 2 factors. It's a great sanity check.
But this table, the rotated component matrix, this is where the magic really happens. It lays it all out for you. You can clearly see that price, value, and quality are all huddled together under factor 1. Meanwhile, support and wait time are clearly part of factor 2. So now you get to be creative. You can name them. Maybe factor 1 is product perception, and factor 2 is customer service. And this is the whole point. A business can now stop trying to track 10 different things and instead focus its entire strategy on improving just those 2 key areas.
All right, we've made it. We've run the analysis, we've interpreted the results. So for our last section, let's just lock in everything we've learned and talk about a few common mistakes to avoid, the kind of stuff that really separates the beginners from the pros.
So here are the big things to watch out for. Please don't forget to run those KMO and Bartlett's tests first. They're your foundation. Also, don't just guess how many factors to keep. Use that eigenvalue rule and the Scree plot to guide you. And seriously, always use a rotation like Verimax. It just makes interpretation a million times easier. If you can avoid these common traps, your analysis is going to be so much more solid and believable.
You know, at the end of the day, it's so important to remember this isn't just a math problem. It's not just about crunching numbers. The whole point of factor analysis is to find that clarity, to uncover that simple, powerful story that's been hiding in your data all along.
So there you have it. You are now officially equipped to go from total data chaos to real analytical clarity. So the only question left to ask is, what incredible stories are waiting to be discovered inside your data?